Welcome back, students. In this video, we're going to do Module 4, Topic 1, Reflections. The standard for this topic is GR 2.1. It's given a pre-image and image. Describe the transformation and represent the transformation algebraically using coordinates. You have standard GR 2.3. Identify a sequence of transformations that will map a given figure onto itself or onto another congruent or similar figure. The objective for this lesson, you guys are going to use rigid transformations to translate figures on the coordinate plane, that's some words missing, and describe the effects of reflections. The essential question, how are reflections used in the real world? Coordinate plane. There's the missing word. Okay, so bell ringer. Page 1 here. Go ahead and pause the video. Please try to do these. And then I'm going to wait about 3 seconds and I will continue. See how you did. All right, so for the bell ringer warm up here on page 1, identify the following lines on the coordinate plane. And we're going to use this up here as our coordinate plane. For A, it says the x-axis. So the x-axis runs left to right. Oops, a little off there. Page is curling up. Here we go. So x-axis. I'm going to make that orange. Let's see. The y-axis, that's going to be the one that runs up and down. I'm going to make it blue. It says use different colored pencils to graph the following lines on the coordinate plane. And we have 5 below. I'm just going to keep going with the colors like I was doing. So for A here, it's y equals 3. So y equals 3 is going to be a line here at y, right here 3. So we're going to go all the way across. So that's y equals 3. All right, next we've got y equals negative 2. So when we're talking y, we're going left to right. The y axis goes up and down, but our y lines are going to be left to right. So for B, y equals negative 2. So we're going to go to where the negative 2 on the y-axis, and that is where our line is going to go. A little straighter than mine did, excuse me there, but that's y equals negative 2. That's your pink line. Excuse me. Let's see. I'm going to go C is x equals 1. So we'll go to x1 here. Probably should have just used a fracture. Okay. It's missing. Oh well. Just keep going like this. So x equals 1. This is our x equals 1. Okay. D is, let's see. Hopefully we can see this. Let's try it. All right, so D is x equals 3. So we're going to go to x3 here. And you can see, see that. All right. And then part E is y equals x. I'm going to make this one red. Let's see. Just a moment. That doesn't work. Okay. So y equals x goes from the bottom corner to the top corner. Let's see here. It looks pink, but it's red. I'm gonna just put I'll just put y equals x so we can differentiate. Okay. Moving on. Sorry, there we go. Just a moment. Unfortunately, this camera, if I pause too much, the video will sometimes just crash at the end, so I just go with it. What you guys see is what you guys get, but that's what we do in class anyway, so you guys should be used to this. Except tomorrow you'll have this already done, so you won't have to wait on me to write it. Anyway, so we're going to recall from before. So a rigid transformation preserves both distance and shape. A reflection or flip, let's do this. So a reflection or a flip is a transformation in a line called the line of reflection. So this is the line of reflection here for this example. Each point of the pre-image and its image are the same distance from the line of reflection. So recall ABC is the pre-image. Hold on, let's do this. So pre-image, and over here is the image. Oops, there we go. Okay. But notice it's ABC, and then the image, the after, is A prime, B prime, C prime. But C is the same distance away, B is the same distance away, and A, if you measure, is the same distance away on both sides. All right, let's see. Bottom of page 1. So reflections in the x-axis. So remember, the x-axis runs this way. Just like up here, it's down here it says the y-axis, and we'll go ahead and just do this. But reflections in the x-axis. To reflect a point in the x-axis, you multiply its y-coordinate by -1. So our coordinate rule, our x comma y, is x comma -y. So our examples here, A is 4, 1. A prime is 4, -1. See that we multiplied 1 by -1, and that puts it the same distance. B is 7, 3. Down here, it's 7, -3. So we're just taking the negative, or you're multiplying it by -1. Excuse me. Reflections in the y-axis. To reflect a point in the y-axis, we multiply its x-coordinate by -1. So your x comma y, in this case, becomes -x comma y. So this is our A, this is our A prime. So 2, 3 becomes -2, 3. 6, 4 becomes -6, 4. Okay, give me just a moment to flip the page here. Okay, get a little practice in on page 2. Oops. New stapled paper. Okay. Number 1. We're at the top of page 2. So it says reflect the figure ABC in the x-axis. So x-axis. This is the x-axis. So we're going to reflect it. And what did we do to reflect in the x-axis? We multiply the y by -1. So our A, B, and C, I'm going to put these up here. So A is 1, 2, 1, 2, 3. So A is 2, 3. B is 5, 1, 2. So 5, 2. And C is 2, 1. Okay. So we're multiplying the y by -1. So 3, so our x's stay the same. Our y's change. 3 times -1 is -3. 2 times -1 is -2. And 1 times -1 is -1. So let's draw this out. Probably should have made it. Well, we're doing this. All right, so A is at 2, negative 3. 1, 2, 3. So this is A prime. B prime is 5, 2. So 5, negative 2, 5, 1. This is B prime. C prime is 2, 1. So 1, 2, down 1. C prime. So we'll draw. Whoops. All you need a protractor. Okay, there we go. Easy peasy. All right. So reflection in a vertical line. Recall, what does the equation of a vertical line look like? And it looks like x equals a number because it's a vertical line. When a figure is reflected in a vertical line that is not the y-axis, the y-coordinates of the image remain the same as the pre-image. Excuse me. Just like up here, the x's stayed the same on the vertical lines, the y's will stay the same. Scoot up here a little bit. Give me just a moment. Okay. So reflection in a horizontal line. What does the equation of a horizontal line look like? It looks like y equals a number. When a figure is reflected in a horizontal line that is not the x-axis, the x-coordinates of the image remain the same as the pre-image. So just like we saw up there, up at the top of the page, it's the same thing here. So let's look at number 3. Number 3 says reflect the image over line x equals 2. I'm going to just do this. And x equals 2 is a vertical line. It's going to be at x equals 2. So we go x2. See that point? And we follow that line up. Okay. So one thing I want to point out before we even do the math here. Notice that point J is on that line. Point J, we've already talked about that when it's x equals a number, the y coordinates will remain the same. So we're going to plot the points here. We're going to put the y's in because they'll stay the same. But for J, it's on the line. So it's going to be the same point. It's not going to change. It's reflected over. You guys will see. I just wanted to say that to begin with. So we start out by plotting our points. So J is 2, 5. K is 3, 7. Get smaller. L is 4, 3. And M is 3, 1. Okay. So, like I said, we're going to reflect over here, but let's see. So this stays the same. So J and J prime are the same. So notice here, M. I'm just going to make these points. You guys you can probably see your paper, but just in case. So M is, let me just do it like this. M is 1 away from the line. So the new M is going to be 1 away from the line. Let me do this. So M prime. So M was 3, 1. M, oh, the new M is 1, 1. Of course, the y coordinates are going to stay the same because it's x equals 2. So I'm just going to plug these y's in. 7. And then, like I said, j is going to be the same. So j is 2, 5. So 2, 5. That's j, and that's also j prime. So k is going to be, it's still going to be 7. So it's still here. This is 1 away. So the new one's going to be 1 away. So k prime is 1, 7. And lastly, L. So L is going to stay 3. But notice this is, let's see, we'll do it in orange, is 1, 2 away from the line. So we're going to go 1, 2 this way. And remember, I've talked about this. If you're looking in a mirror, if you touch your nose to the mirror, your nose is touching the mirror on the other side. This is the same thing. If you're further back, you're further away. It's going to be the same as your reflection. So here, make sure I'm right here. 1 away. Oh yeah, here. This it's like I'm missing a point here. Here, this is L prime, and L prime is 0, 3 because it's 2 away. Sorry, I got ahead of myself. Then we've already made M. So notice it's reflected. It looks the same on each side. M was 1, 1. But in this case, you have to graph it to get the point because you want to see how far away it is. All right, number 4. We're going to reflect this triangle ABC in line y equals 1. So y equals 1, that's this point right here. So this is the line. Terrible drawer. This is the line, y equals 1. As terrible as it is. All right, so let's plot our points first. So A is 2, 3. B is 5, 2. And C is 2, 1. Okay. That was not good because we've got to put the triangle there. Let me just put C is 2, 1. B is 5, 2. And A is 2, 3. Okay. Because that's going in the way. All right. So we're reflected in this line. Remember the x's stay the same. When it's y equals, when it's y equals a number, then the x's stay the same. So our x's are going to be 2, 5, and 2. But now, so let's do this. So A is 1 away from the line. So it's going to be, no, that's not 1, that's 2. 1, 2. 2 away from the line. So it'll be 1, 2. 2 there. Let's see, what color are we going to make this? Yeah, let's do this. Okay. So we're going to write here for A prime. And this is 2, -1. Okay. Sorry about the different colors over here. All right, C is on the line, so it stays the same. So we reflected in that line, we're staying right there, 2, 1. So from here to here. And then B's over here. B stays 5 because it's all the way out here. Notice that B is 1 away from the line, so the new B will be 1 away from the line. So B prime here. So we draw from here to here. We draw from here to here. See, I told you that'd get in the way. But notice it's reflected, and my drawing's not perfect, and the B was 0, 5, 0. Okay. All right, let's move to the bottom of page 2. Let me see. So, 2 different looks in the packet here. Okay, this is on the next page of 1. I'm gonna draw these down here. So let me just scoot down a little further, right there. Yeah, so I'll draw the problem here, but we'll talk about this well. Let's just draw the problem down here. So, quick way to make your own little grid or coordinate plane here. I just go 5 because I know about what we're looking at in the numbers here. So number 5 says when G, that's 0.4, negative 3. So we're 1, 2, 3, 4, then negative 3, 1, 2, 3. So this is G. Is reflected over x equals 1. Let's see, hold on. So x equals 1. So it would be here. It says the image is located at G prime blank blank. Okay, well, if we're right here, we're at 4, negative 3. So we are 1, 2, 3 from, we're 3 from the line. So we're going to go, this is 1 here. So 1, 2, 3 from the line. It's going to put us, let me draw this in color. So it's going to put G prime. So it's still at negative 3 because it's reflected in the x equals a number. So the y coordinate's negative 3. The x coordinate moved because we were 3 from this line and we're 3 over here. Our x coordinate changed from 4 to, let's see, so 0, negative 1, negative 2, negative 3. No, wait a minute. Let me make sure here. Hold on. We were on 3. We moved 3. 1, 2, 3 to 1, and then 1, 2, 3 to negative 2. Okay, making sure. So the new point is negative 2, 3. Notice that because it was an x equals a number, the y stayed the same. The x changed. All right, number 6, G, same point. So we're going to be, let's just draw G where it was at before. It's at 4, negative 1, negative 2, negative 3. G, 4, negative 3. Okay. Says it's reflected in over y equals negative 1. So y equals negative 1 is right here. That makes that the line. So notice we're a good bit further away this time from the line. So let's count. It's harder when it's not a grid, but we're over here at 4. So we're going to have to go 1, 2, 3, 4. To get to negative 1, it's 5. So that was 5 over. So now we have to count from -1, 5 over. It's going to go beyond my 5, so I'm going to have to draw a 6th one. As a math teacher, you know. 1, 2, 3, 4, 5. So our G prime, write this in a red. So notice this is still, did I mess that up? I did mess that up. Oh, goodness. Okay, back this whole thing up. I'm going to redraw my line. I messed up. Y is -1 is right here, not right there. So we're going here. So this crap over here is just forget it. Okay. So this is our line. This is Y equals -1. Big dummy over here. Okay. So I knew our numbers weren't looking right. So we're here at -3. So we're going to go 1, 2, 3, 4 takes us to, it's not Y equals -1. I went all the way past it. Still messing up. From -3 to -1 is 1, 2. So we're going to go up 1, 2. This puts our new G. Let me find a different color right here. G prime. Notice, so we're still over here at 4 because our x's don't change. That was how I knew I had messed up. Okay, so that's the 4. Still can't see it. Write it like this. Okay. And so we are now at 2. So instead of -3, we're at +2. See, we were 1, 2. Sorry for the confusion. Okay, flip it over. Page 3. Just double check. Oh, forgot the notes right here. Let me go back to 2 a second. Yeah, 3's the last page. 2, I did skip the coordinate rule here. So reflection in the Y equals X line. That is the line that goes diagonal across the coordinate plane. It goes all the way down to the bottom, but we're just looking at this particular quadrant. But so reflections in the Y equals X line, to reflect the line in that a point in that line, you interchange the X and Y. So X comma Y becomes Y comma X. Okay. My apologies. So now we need to do that for these last 3 problems, and that is the end of this topic. So, okay, I'm going to use this to draw against. Tell you guys, it's tough getting old. Okay. This is Y equals X. That's that line. X. Okay. Number 7, reflect the figure in line Y equals X. So first thing I'm going to do, I'm going to get my coordinates. A, B, C, D. So A is 1, -4. B is 4, -4. C is 4, -2. And D is 1, -2. All right, so the rule we just learned is that when we reflect in that line, your Y, X comma Y becomes Y comma X. We just interchange our X and Y coordinates. 2, 1, 2. So we're just going to interchange those. I'm going to put these in red. So it's -4, 1, -4, 4, -2, 4, -2, 1. Let's graph these four. So -4, 1, A prime, -4, 1, 2, 3, 4, -2, 4, C prime, and then -2, 1 is D prime. So notice it. Okay, well, yeah, it's not straight on, so it's at an angle. So it's a little different, but yes, it's over there. That is how. Looks weird, but that is the answer. All right. Lastly, number 8 and number 9. Number 8 says, describe the reflection and explain why this is a rigid transformation. Okay. So notice, so C is here and here. It's a reflection. So you see this is 2, this is 4, this is 6. So these are counting 2. This is in the middle. So this is at a 1. This is at 1, 4. This say, and this is at 5, 4. So notice that they both have the same y coordinate, so we're in a x equals a number. Let's see how far apart these guys are. So it's 1, 2, 3, 4. So they're 4 apart. So from here, 1, 2, 3, because these count as 2, 4. So these are 4 apart. So we meet in the middle. 1, 1, 2, 2. So if you, let's see. So if we draw a line, because it's meets in at 3. So let's draw a line. This line is x equals 3, and that's where it's reflected. And how do we know it's rigid? Well, you see they're all the same spot, so they're congruent. So that's how we know it's a rigid transformation, because it retained, it preserved distance. So distance over here, this is 1, well, these are 2. So 2, 4, 5. So this is 5. And this is 2, 4, 5. This is going to, so they're the same distance apart. All right, number 9. Describe the reflection and explain why this is a rigid transformation. Well, you guys can look at these and see they're the same size. So I'm not even gonna fool with that. You see S is here, so it's a reflection, and it tells us it's a reflection. Let's see how far the S is. So -2, that's 2 away, that's 2 away. You notice right away. Hopefully you did. If not, you'll get there with practice. This is reflected in the y-axis. Okay. All right. Have a good night, guys. If you got any questions, ask me in class or send me a Teams or a message in Focus. Okay. See you later.